Hello everyone, and Happy New Year from everyone here at AISC. We are pleased to bring you the first webinar of 2020 today, Are You Properly Specifying Materials?, presented by Larry Kruth. My name is Nate Goner for AISC Education, and I will be the moderator for today's webinar. I would like to introduce our speaker today, Larry Kruth. Larry is the Vice President of Engineering and Research at AISC in Chicago, a role he has held since 2016. Prior to that, Larry spent most of his career with Douglas Steel Fabricating in Lansing, Michigan, most recently in the role of Vice President. He has been very active in the industry for many decades, serving on numerous committees, participating in the leadership at the National Student Steel Bridge Competition, and serving as an adjunct faculty member at Michigan State University. He has notable expertise in fabrication and erection, quality systems, safety, and connection design, and is a licensed engineer. Larry, thanks for being here, and I'll now hand it off to you.
Thanks, Nate. I'd like to start by asking all the engineers on the line, have you ever picked up an old set of specifications, one from a previous job, or a set of general notes and thought, can I use these on my present job? Well, we're going to try to answer that question today with this webinar, Are You Properly Specifying Materials? Now, what does properly specifying materials actually mean? It actually means, are you using the current ASTM standard, and are you using the preferred material, usually the most economical material to use on your project? This webinar is actually based upon an article that appeared in Modern Steel Construction in April of 2018, written by Jonathan Tavares of our Solution Center. I advise all of you to download this article. There's a lot of good information in this article. It's a free download from our website. Now, those of you who have been longtime readers of Modern Steel Construction may remember this series from January, February, and March of 1999. It was a three-part series on this same subject, Are You Properly Specifying Materials? Well, after we did that in 1999, about 5 years later, we combined it all into one article in January 2004. Keeping with that same progress, in January 2009, we published the article updated again because material changes every few years. We began to realize that maybe every 5 years was too long. So we went to every 3-year period starting in February of 2012. Then we published it again in February 2015, and again the most recent one in April of 2018. So there's been a long history of these updates, and we're trying to stick with a 3-year update so you understand what has changed in the industry with materials. So where is the source of a lot of this? A lot of the source comes from ASTM Annual Book of Standards. Now this is actually an older picture of all the standards from 1989. And the reason I showed you this is it's a lot of booklets. To accumulate all these that you would need to deal with structural steel fabrication, it would cost you probably a few $1,000s to accumulate all these, because a lot of these contain material for structural steel in one, bolts in another, maybe plates in another location, so you need to accumulate all of these. Well, about 26 years ago, AISC decided this may not be an economical thing for all of you to purchase at that time. So we contacted ASTM and said, here are the critical specifications, ASTM standards that we need to have available for steel fabrication, and we published a book. Now this is the most recent one from 2019. This is available on our website for purchase, but it contains everything you should need most commonly for structural steel fabrication. The member price is $280. The non-member price is $560. but I want to make you aware that this is a great savings over the many thousands of dollars you would have to do to purchase all of the ASTM standards separately through all of the annual books that are required. So what is included in ASTM standards? Well, every standard contains ordering requirements, also the mechanical requirements, the yield strength, the ultimate strength and elongation, the chemical composition of all the materials, process requirements, what the manufacturer needs to know in order to make that material that meets that ASTM standard. Also, the testing requirements. What tests does the manufacturer have to perform to ensure that he meets all the requirements of the specification? Tolerances, which for structural steel are mainly covered in ASTM A6, which has all the tolerances. Provisions for repair of defects. Now there are times when material is received from the mill that it may have some minor mill defects. There are provisions in the ASTM standards on how to repair those defects and still meet the standards, but these are minor defects. Also reporting requirements. What is required by the manufacturer of the material in order to report to you what they are doing? The mill test reports. One thing I wanted to caution you is about over-specifying material. Well, over-specifying material is sort of like taking a square peg and trying to put it into a round hole. You have to chip sides off of that square peg in order to get it into the round hole. Every one of those chips is money. So what do I mean by over-specifying material? Such as requiring Sharpie V-notch testing of all material, even though it's not required. Specifying 70 KSI material, even though 50 KSI material might work. Even specifying atmospheric corrosion resistant material when it's not required. So don't over-specify material, because if you over-specify it, it'll still meet the strength requirements or the requirements of your design. But all those chips cost money that you don't want to have to expend if you don't have to. So what about under-specifying material? That's sort of like taking a round peg and putting it in a square hole. Now if you notice, there's gaps all along the edges of that round peg going into the square hole. Well, if you under-specify, you have actually an opposite problem. You may not have a material that meets all of your design requirements. So you may want to be cautious about that. Properly specify your material. So where can you find information about what is the proper specification for material? Well, there are a number of sources. First is the specification for structural steel buildings and the seismic provisions for structural steel buildings. This is the 2016 edition. These are free downloads from our website, but those of you that have the 15th edition Steel Construction Manual will find these are bound in the Steel Construction Manual as well for the specification of structural steel buildings, and the seismic provisions are in the 3rd edition Seismic Manual. So what does it look like? Well, if you go to section A3 of the specification, you're going to see a description of structural steel materials and also a description saying ASTM designations. Continuing on, you'll see all these different ASTM designations that are appropriate or the proper designation for each of these types of shapes that you see here. And this goes on for quite a few pages in the specification. What assurance this gives you is that if you pick one of these that are here, all the sections and all the formulas that are in the specification will work with all of this material. That is what the specification is based on. If you go outside of this, there's no guarantee that the formulas in the specification will work. Well, that's a very long list. Another place to look may be the AISC Code of Standard Practice for Steel Buildings and Bridges. This is also the 2016 edition. Section 6.1 of the Code of Standard Practice states, unless an alternative system is established in the fabricator's written procedures, shop standard material shall be as follows. So this really tells you what is the standard material that you might see in every shop. Now this is based on 2016 information. So when you look at this list, it's a much shorter list, but lets you know what most fabricators are going to have in their shop to use. So a couple of things I want to point out here. And the first I want to point out is HP shapes. The HP shapes prior to 2016 were A36 material. Now they are A572 grade 50 material. Another item I want to point out is HSS shapes. The proper designation for what fabricators will have in their shop is ASTM A500 grade C. We're going to deal with this much more extensively in this presentation today, so I won't spend any more time on that at this time. Another great resource is the Steel Construction Manual. This is the 15th edition. But if you go to Section 2 of the Steel Construction Manual, there are a series of tables. And this is Table 2-4. It says applicable ASTM specifications for various structural shapes. I wanted to point out that there are gray bars and black bars on here. And you'll see for each of the shapes, you'll see a gray bar, and that means it is available, but the black bar means it is a preferred specification. So if you're wondering what you should be specifying, that's one good place to look, is to look at Table 2-4 for the ASTM specifications for various structural shapes, and go for the black bars for the designation. Also, Table 2-5 has information on plates and bars, exactly the same way with the areas grayed out and also the bold black areas, which is the preferred specification. Table 2-6 deals with structural fasteners. Similarly, this has the black boxes and also the gray boxes on here. So as I said, this presentation is based upon the article that was in the April 2018 Modern Steel Construction, Are You Properly Specifying Material? Well, this is a live version. Now what that means when it's a live version is it's a summary. There's a lot more information in the article. Again, I said it's a free download. Download it. It's a great resource to have on hand. I'm also going to give you a little insight into the future. There are some issues I'm going to be talking about today that aren't part of the specification and that are going to be coming out in the future to make you aware of what we're looking at this time. So stay tuned for that. Well, let's start right into it. Let's start with W shapes. The proper designation ASTM's standard for W shapes is ASTM A992. I want to make it clear, it's not ASTM A992 grade 50. All ASTM A992 is 50 KSI material. So the proper designation for W shapes is ASTM A992. Now, if you need atmospheric corrosion resistance in your material, you would specify ASTM A588. Now, A588 also has a yield strength of 50 KSI, but the tensile strength is 70 KSI, slightly higher than A992. I want to also make you aware that atmospheric corrosion resistance material A588 is more expensive than A992 material. So only specify that when you need it. So if you need something really big, a really big shape, there is a new standard that has come out more recently. This is in the manual at this time and in the specifications. For W shapes, it's ASTM A913. Now, this is actually a slice of a W 36 by 925 made from ASTM A913 material. Jonathan Tavares, who was the author of the article, is holding this slice. Now this is about 3/16 of an inch thick, and it weighs about 15 pounds, but you can see how massive it is. See the thickness of the flanges. It's a very large shape. Now ASTM A913 is most commonly available in 3 different grades: grade 50, grade 65, and grade 70. Also, quite a few shapes are available in A913. You can see we started at W44 by 335. We even have a W36 by 925 on there, but also goes as small as a W8 by 10. Now this reflects information that we received from ArcelorMittal, Nucor Yamato Steel, Gerdau, and Steel Dynamics. Now I want to make you aware that not all of these shapes are rolled by all of the mills, and they might not all be readily available. So before specifying ASTM A913 material, make sure you check with your local fabricator on the availability of that material. And there is a premium for A913 material as well. So A992 will be cheaper than A913. One of the advantages of this grade is that preheat is not required for welding grade 50 and grade 65. Now what does preheat mean? Well, as material gets cold, like around 30 degrees or 32 degrees, it's necessary to preheat it to get to a proper temperature before you do your welding. Now just think about trying to preheat that shape that Jonathan's holding there and how long it would take it to get up to a proper temperature to be able to do welding to develop the proper penetration of your weld. You may be preheating that for 24 hours in cold weather to get it to the proper temperature. So eliminating the need for preheat for grade 50 and 65 is an advantage. Now grade 70 still does require preheat. Also want to make you aware that the grade 65 and grade 70 column tables do appear in the 15th edition Steel Construction Manual. S-shapes. S-shapes are commonly available as A36 material, 36 KSI material. They are also available as 50 KSI material, but if you notice, I have a couple asterisks on the 50 KSI material. Also want to make you aware that when you're looking at the flange thickness, it's actually the average thickness of the flange, not the thickness at the toe. But when you're looking at those different ASTMs for 50 KSI material, S-shapes are available in A572 grade 50, A529 grade 50, or even A992. A lot of structural material is available in A992. So you do have different options if you need 50 KSI material for an S-shape. Atmospheric corrosion resistance is again A588 material. This is very common for atmospheric corrosion resistant material is ASTM A588. Not any difference that we looked at for wide flanges. Channels. We're going to talk about C-shapes and also MC shapes. There really isn't a lot of difference between what we looked at for channels and what we looked at for S-shapes. The same ASTM numbers are available for channels as they are for S-shapes. What I can tell you is it is more common for you to find A992 channels in a fabricator's shop rather than A36 channels. A992 is probably the most common material you're going to find in a fabricator's shop for channels. I also want to talk about a unique channel shape, an MC12 by 14.3. It's a stringer channel. Now this product was developed to act as a stair stringer. Now the unique property of this product is the flange is 2 1/8 inches wide, which means that you can actually take a post from a handrail and weld it to the top of this flange all around. You wouldn't have to crimp it to fit on a smaller flange. The only other shape that possibly would work for that application is a C12 by 20.7. And again, this would be a case about over-specifying material. If you specify a C12 by 20.7, it's going to work. It's going to have a wide enough flange for you to make it work. But you're actually buying more material than what you need. If you specify an MC12 by 14.3, it'll be less expensive. I'm going to caution you as well, though, please check with your fabricator before specifying it to make sure it is available in your area. Angles. Again, angles are the same as S-shapes. You have 36 KSI material and more commonly now 50 KSI material. But I do want to talk to you about large leg angles. Large leg angles are available in 10 by 10 and 12 by 12. In the picture, you see a 12 by 12, which is adjacent to a 3 by 2.5 angle, so you get the idea of scale. Also, you can see the quarter in the picture, so you actually can see the scale we're looking at there. The 10 by 10 angles are available in 3/4 to 1 3/8 thickness, and the 12 by 12 angles are available in 1 to 1 3/8 thickness. And this is all defined in ASTM A6. Remember, I told you A6 has all the properties of the dimensions for all structural shapes, as well as all the tolerances. All the tolerances also appear in Part 1 of the Steel Construction Manual if you'd have that handy at the same time. T's. Well, WTs are the same as W shapes. STs are the same as S shapes. Now why is that? Well, WTs are not rolled at mills. WTs are W shapes that are just split at a fabricator's shop down the middle. Also, STs are just S shapes that are just split down the middle in fabricator shops. That's why the specifications you use for W shapes are what you would get for WTs, and the specification you use for S shapes is what you get for STs. HP shapes, bearing piles. Now, as I mentioned earlier, HP shapes are all now A572 grade 50 material. Now, these are more commonly used in foundations as being driven down to provide a bearing for your foundations, but I have seen these used at times as column shapes. So keep that in mind if you're using this for any of those applications. Use A572 grade 50 when you're using this material. Take advantage of the strength. Don't default to the old A36, 36 KSI material. HSS shapes. Well, for years when we were dealing with HSS shapes, I think everybody looked at HSS rectangular shapes, and they always have specified ASTM A500 grade B. Well, I can tell you that you should not be specifying that now. What you should be specifying is ASTM A500 grade C, because all domestic HSS mills are producing all their material meeting A500 grade C, which is 50 KSI as opposed to the 46 KSI which was used for grade B. So if you specify A500 grade C, you can take advantage of the added strength. So keep that in mind. Take advantage of it. In fact, you're going to find out that even if you specified A500 grade B, when the mill test report is received, it'll probably say A500 grade B/C, which means it meets all the requirements of C, because if you meet the requirements of C, You also meet the requirements of D. Take advantage of the added strength. I also thought it significant to point out that HSS rounds, if they are A500 grade C, have a slightly lower yield. They have 46 KSI for the yield. So keep that in mind. Rounds have a slightly lower yield than the rectangular. They're 46 KSI. When you're dealing with atmospheric corrosion resistance, HSSs have their own standard. That's A847. So you don't use the A588 for HSS shapes. It's ASTM A847, a totally different ASTM standard for atmospheric corrosion resistance. And you may see HSS being used in like pedestrian bridges for this application. A newer ASTM standard for HSS shapes is ASTM A1085. Now if you notice, this has the same yield as the A500 grade C, 50 KSI. But there are some differences. One of the major differences is when you're using A500, you'll notice that it's tabulated with a nominal wall thickness and also a design wall thickness, which is 7% less than the nominal wall thickness. That was due to manufacturing procedures that are spelled out in A500. With A1085, you now can use the true wall thickness. So the nominal wall thickness is now the design wall thickness for A1085. The yield of this material also has an upper limit of 70 KSI. So keep that in mind as well. There are more controls on the yield. A1085 also has some added toughness requirements. The CVN is 25 foot-pounds at 40 degrees. I do want to point out that you need to check with your local fabricator for availability. ASTM 1085 is not readily available everywhere, so check with your local fabricator before specifying it. But if you can use it and it is available, you can get some strength requirements, strength advantages by using it, because you can use the true wall thickness. Also, A1085 and A500 now allow up to an 88-inch periphery and a 7/8 inch wall thickness. This is increased for A500, where it used to be limited to a 64-inch periphery and a .688 wall thickness. So this will allow you to get an 18, 20, or 22-inch square and a 16 by 12 or a 20 by 12 and a 24 by 12 rectangle. Also, I wanted to point out, even though it's not noted on the slide, there is a new standard that can accommodate even larger cross sections. ASTM A1065 allows up to 192-inch periphery and a 1-inch wall thickness. I do want to call to your attention, though, check with your local fabricator for availability before specifying any larger sizes. But if you need these sizes for your design, they are available. Steel pipe. Steel pipe has the same ASTM standard that it's had for a long time. It's ASTM A53 grade B with a yield strength of 35 KSI. I need to point out a couple important things. Round HSS is not steel pipe. They are made to different ASTM standards. Remember, we talked about round HSS is A500 grade C. Steel pipe is A53 grade B at different strength levels. The A500 grade C is 46 KSI for the yield, while the A53 grade B is 35 KSI. There is a little bit difference in the way they're designated. They're similar, but the two designations have similar cross sections. For example, when you're looking at steel pipe and you're specifying a 6-inch standard steel pipe, you're actually getting a steel pipe with a wall thickness that is 6.625 with a wall with an OD, of 6.625 and a wall thickness of 0.280. So when you are specifying a round HSS, it's most common to specify a dimension like you see on the left, HSS 6.625 by 0.280, because those are the most common sizes that match the pipe standards are most commonly produced. So don't specify pipe, you can specify the HSS and take advantage of the added strength you're going to get over the A53 grade B steel pipe. There's another advantage. Because A53 is pipe, there has to be hydrostatic testing required for that pipe. That's an added cost for A53. Well, if you're using it in a structural application, you don't care if it holds water, just so it works structurally. That's the most important part. So specify, when you're dealing with a round shape, a round HSS, A500 grade C. Plates and bars. We can distinguish between the two by saying that plates are generally wide with the faces rolled, and bars are generally narrower with the faces and edges rolled. Plates generally come from plate mills, and bars generally come from bar mills. But in terms of materials, we can say they're both the same. So plates and bars are available as either ASTM A36 or ASTM A572 grade 50. So that is very common for both of them. On this slide, I have a couple asterisks shown. Even though it's more common today to have 50 KSI material than 36 KSI material, there are some limitations. 36 KSI material is only available up to 8 inches thick. Over that, the strength drops to 32 KSI. For A572 grade 50, the maximum thickness covered is 4 inches. Keep that in mind. These are all tabulated in the Steel Construction Manual if you wish to look at this, but that's why the asterisks are on this slide. Now for atmospheric corrosion resistance, we're back to the old standby A588 material, ASTM A588 material for atmospheric corrosion plates. So if you need that in those applications, that's what you specify. Fasteners. We're going to talk about a number of different types of fasteners here. Again, I'm going to refer you to Table 2-6 of the manual, which deals with all the fasteners. You can see the gray boxes and the black boxes to help guide you about what you should be specifying as the most common material. So let's talk about bolts. If you notice, this slide is designated as old. For years, and everybody knows, we've specified ASTM A325 and ASTM A490 for hex head bolts. And for tension control bolts, we specified ASTM F1852 and F2280. Well, that was common up until 2015. In 2015, ASTM came out with a new umbrella specification, F3125. What they had discovered that there were differences with the old standards in the way they were specified to be manufactured and tested. So trying to develop some commonality in all the standards, they developed a common specification, F3125. But to make life easier for all of us, they kept some grade designations that are common. For hex head, you have grade A325 and grade A490. For tension control bolts, you have grade F1852 and grade F2280. So the proper designation is ASTM F3125 than with the proper grade. I want to talk about these bolts, which are tabulated in the steel manual. They are and in the specification, ASTM F3111 and ASTM F3043. These are super high strength bolts. These are 200 KSI bolts. They presently are not available in the United States. When we published the last specification, these were available in the United States. Due to manufacturing issues, they are only available in Japan at this time. But there are some limitations on the use of these bolts, even if you wanted to use them. They can only be used in non-corrosive environments. So they can't be used in conditions where they would be wet all the time, because they will corrode. So there are a lot of limitations with the use of these bolts, and they are not available in the United States. We hope they will become available again soon, but they presently are not available. Now I'm going to give you one of those peeks into the future at this time. There's another ASTM standard for high-strength bolts, ASTM F3148. It's called the TNA bolt. It stands for torque and angle. This bolt is presently being balloted by RCSC, which is the Research Council on Structural Connections, and it is presently expected to be in the next version of the specification, and it's also being balloted in the AISC specification for the next version, and that is expected to be included at this point in time. Some really unique features about this bolt that I wanted to talk to you about. Grade A325 bolts are made from 120 KSI material. Grade A490 bolts are made from 150 KSI material. While ASTM F3148 is made from 144 KSI material, which falls right in between those two grades. So it has an added strength over grade A325, and it has an added benefit that it can be galvanized. Grade A490 bolts cannot be galvanized. This can be galvanized. So what's unique about this? I'm not going to spend a lot of time on this, but it has some unique installation methods. It has a special gun. It is snug tightened, and then you set a degree of rotation on a dial on the gun. And it takes it and rotates it the proper amount to get the proper torque. That's why it's called torque and angle when you tighten it. The little spline on the end does not break off of a TNA bolt that's used to develop torque, contrary to breaking off on a TC bolt. We'll talk about other fastener products. We'll talk about ASTM A563 nuts. That is the preferred specification for heavy hex nuts that are used for all steel-to-steel connections and all bolting applications. That is referred to in Section 2.4 of the RCSC specification. Now, as I said, the RCSC specification is a free download at either our website or the RCSC website at www.boltconsole.org. Now, the preferred material for hardened washers is ASTM F436. Now, this specification covers both flat and beveled washers. They recently added an extra thick option that was added for cases where the RCSC specification in Table 6.1 requires a 5/16 inch thickness when oversized or slotted holes are used in the outer ply of a steel-to-steel joint. The DTI washers, the ASTM A959, are compressible washers. Now, these have little bumps on them that as the bolt is tightened, they will compress. So you can determine the direct tension. By using a feeler gauge, if you get refusal of this feeler gauge, the bolt will meet its maximum tension that's required. So these are a way to check direct tension if you don't have a tension control bolt. These could be great for hex head bolts for direct tension purposes. Anchor rods. So anchor rods are not bolts. These are rods, and they have their own unique ASTM specification. F1554 grade 36, F1554 grade 55, F1554 grade 105. Now, F1554 covers both nutted and hooked anchor rods. Most commonly, what you're going to find that is going to be supplied is an F1554 grade 55, usually with supplement S1. Now, supplement FS1 means it's weldable. Grade 36 allows you to substitute grade 55 for grade 36. It's important when you're specifying F1554 grade 55 anchor rods that you specify that supplement S1 to make it weldable. Because if you have a situation where you may not have sufficient projection on an anchor rod, you need to add a little threaded portion to it, or even weld it to a plate washer, or even to the base plate some way, you want to make sure it is weldable one way or another. Grade 105 is not weldable. It's a very high strength. It was developed to be close to what a high strength bolt material is, but that's why it was developed. It is available if you need something high strength. Also, I wanted to talk a little bit about anchor rod washers. And I want to refer to you to Table 14-2 in the manual. What you're going to find, this shows you the anchor rod diameter and also a hole diameter, and a washer size and a washer thickness for each diameter of anchor rod. Now, all of these hole diameters were coordinated with ACI 117 for the tolerances ACI 117 has for the placement of anchor rods. So the hole diameters are larger to accommodate this tolerance. Now, the washer size is sized sufficiently to cover the hole, and also a proper thickness so you will not have a problem developing the strength that is required. So keep that in mind. Also keep in mind, a washer doesn't need to be round. It can be square. Either one will work. Welds. We're going to talk briefly about welds. We're only going to talk about filler metal. It is still the same as we've always talked about, 70 KSI material. Also want to talk about an AWS standard A5.36. When that was developed, it was hoped to supersede A5.20 and A5.29. At this point, they are all commonly available, and it is not expected that A5.36 will superseded at this point, but you can still specify A5.36, A5.20, or A5.29. For a whole lot more information, I would recommend that you download Design Guide 21, which is a free download for AISC members from our website. It was written by Dwayne Miller of Lincoln Electric. It is a great publication, has a lot of information on welding. There are a few other things in the article, and we're going to go over these rather quickly. Raised pattern floor plates are ASTM A786. Now, as a floor plate is designed, it's seldom strength is a consideration. ASTM A786 is commercial grade. It mainly specifies a pattern to be on the plate, and it specifies a maximum carbon content, but no specified mechanical properties. Also, crane rails are A759. Shear studs are rather unique. They do not have an ASTM standard. They are specified in AWSD 1.1, Clause 7.2.6, Type B. So if you want to find information on shear studs, you need to look at AWSD 1.1 to find that information. Threaded rods are a lot of different ASTM standards that are available: A36, A193, A354, A449, and A572. Also, castings and forgings are in ASTM A27, A958, and A668. A lot of this is covered more in depth in the article that we mentioned, the April 2018 article on modern steel construction. Bridges. There's an umbrella specification for bridges. It's ASTM A709. and it covers a multitude of grades: ASTM A36, A572, A982, A588, and 3 high-performance steel grades. It also covers some high-performance steel grades that are available only in plate form. Grades 50S and grade 50W are available in shapes. Grade 50CR is available in plates. And there's a whole lot of other information on toughness requirements and what's acceptable use where the corresponding parent material is specified. Again, this is covered more in depth in the article. And also, read ASTM A709. It'll give you a lot of good information. Now we're going to give you another little peek into the future. In the Steel Construction Manual, in the 15th edition, all the tables for connection material are based upon 36 KSI material. While beginning in the 16th edition, there's going to be some changes. The most common material for connection material is no longer 36 KSI material. All of the tables for connection material in the 16th edition of Steel Construction Manual will be based upon 50 KSI material. That is the most common material available for connection material today. So in summation, remember, do not over-specify material and take a square peg and try to put it into a round hole and chip it off and cost more money for every chip you have there. Also, do not under-specify material and try to put a round peg in a square hole and leave a lot of gaps. So where can you find a lot of this information? Well, there's a lot of information free. You can find it in the specification for structural steel buildings, and the seismic provision for structural buildings, and the Code of Standard Practice for steel buildings and bridges, which are all available as a free download from our website. Also, you could purchase the selected ASTM standards for structural steel fabrication from our website. That is available. It's a great resource. It's a small booklet that has a tremendous amount of information in it. And remember, there's a lot of good information in the Steel Construction Manual as well as what is the preferred material. And the article that Jonathan Tavares wrote in April 2018 has a lot of good updated information, and there will be a new one coming out in the near future as well. So this is one of those times, if you do everything right, everybody's going to be happy. And why will they be happy? You won't get any RFIs. You won't have to spend time trying to answer questions when somebody says, can I use this instead of what you specified? Specify it properly to begin with, and you won't have that problem. So, as part of this presentation for your PDH, there will be a final exam question. So here is the question. Where could you find the preferred material for all structural steel material? A, AISC Steel Construction Manual. B, ASTM Book of Standards. C, AISC Selected ASTM Standards for Steel Fabrication. Or D, Modern Steel Construction. Now, Nate, I'm going to turn it over to you for the polling question.
All right, Larry, I'm going to go ahead and move us into the polling module. So there you can see the question that Larry posed to you all, and you can participate by selecting the radio buttons next to the answers you think are right. Now this question, you can select more than one right answer if you think more than one is correct. So I'm going to give you guys some time to put those answers in. The question is where can you find the preferred material for all structural steel material? The AISC Steel Construction Manual, the ASTM Book of Standards, the AISC Selected ASTM Standards, or in Modern Steel Construction. We're going to wait for the answers to slow down here, Larry.
Okay.
Okay, so I think they're starting to slow down. So we're going to go ahead and close the poll. And Larry, it looks like we have some interesting results here. 75%
Yes, we do.
think that A is the correct answer. About 40% think C is the correct answer. And then we have 28% thinking it's B and 19% thinking it's D. So what are the answers you're looking for here, Larry?
You can go to the next slide. A and D. Now the key to remember was preferred material. Remember those tables in Section 2 of the Steel Construction Manual had those black boxes? That's why a lot of people pick that. But also remember that the Steel Construction Manual was published in 2017, and the article on modern steel construction was updated in 2018. So there's more updated information in modern steel construction. So you'd always want to use both of those together. Now the answer in C, the selected standards, has all the standards, but doesn't tell you which one's preferred. Preferred references will be in A or D, and the ASTM Book of Standards will just have a lot of information.
All right. Well, thank you, Larry. So now we have some time, and we're going to go ahead and try to get to some questions that have come in from the audience. And there are a lot of questions that have come in from the audience, so we'll see how many we can get to before we're just completely out of time. So for the first question, I'm going to go back to slide 46, and this is a series of slides where you're talking about channels and angles. And I had a question about dual and tri-certified materials. What is that exactly? And how does it relate to what information has been put into the Steel Construction Manual?
What's presently in the Steel Construction Manual is 36 KSI material. It doesn't mean that 50 KSI material is not available. And you can do your connection designs or any designs with any of those with 50 KSI material. Now obviously if you have dual certified material, which means you may have material that meets A36 and A572 grade 50, you can use 50 KSI for your designs. So that is possible. So there, you can have dual certified material, which is almost the same as what we talked about when we were talking about HSS shapes, where A500 grade B/C, you may get an angle in that the mill test report says A36 and also says it meets A572 grade 50.
All right. So keeping kind of in the same area, you mentioned A992 steel being common for channels, and there's a number of questions about that. I guess the main question being, why is A992 not indicated as the preferred material specification in the manual for channels, if that's the case?
Well, actually, if you read the article on modern steel construction, it's going to state that, which is one of the reasons why I mentioned modern steel construction as being a good source, because we have received updated information saying that A992 is the most common grade available for channels at this time. At the time when the Steel Construction Manual was published, that was not as prominently evident to us. It is now.
Okay. So there's a number of questions about the changing specifications for HSS. And let's see here. The question is can you explain, is there any difference in the tolerances for A500 grade C as compared to grade B? Or is that only the 1085 that has the different tolerances?
Yeah, there is no difference in tolerances between A500 grade B and A500 grade C. 1085 has a tighter tolerance where you can use the true wall thickness.
Right. I'm going to move forward to slide 64. So there's some questions about HSS versus steel pipe. And I guess one of the prevalent questions is what types of structural advantages might there be to a steel pipe versus an HSS? And I guess a corollary question is are steel pipes more readily available than HSS? Do we know any comparison of the availability between pipes and HSS?
It's very common that if you are specifying a steel pipe and it's to be used for a structural purpose, you will probably be receiving an A500 grade C round HSS rather than the steel pipe. The only time it would be critical is if you need to use it for transmission of fluids. And then the A53 grade B is critical to be used. So there really is no advantage for a structural purpose to use steel pipe. To the best of my knowledge, I'll use the best of my knowledge, all of the steel pipe sections, the diameters, the standard shapes, the extra strong, the double extra strong, should be readily available as A500 grade C material. So take advantage of that added strength.
All right. Going to move forward. A couple of questions about, in our fastener section, about anchor rods. First, there's one kind of general AISC question, is when did AISC start encouraging the rod terminology for anchor rods?
Wow. You're making me think back. I'm going to have to think it probably, it's going to be probably close to 15 years. And mainly the reason was they wanted to make sure people understood these are not bolts. These are made from rods. Even when they were called bolts in the past, they were made from rods.
All right. So another question about the specifying of anchor rods. Is the fabricator allowed to supply F1554 grade 55 with the S1 supplement when the engineer, without the engineer of record approving, when the engineer has only specified grade 55 without the supplement?
Well, the supplement only adds weldability to it. And I think it's to everybody's advantage to add the supplement to make sure it is weldable in case there is a problem with it. If there is a problem that develops due to the placement in the field where the anchor rod is placed too low or some other unusual issue that you have to weld to it, it's always best to always specify the supplement. There's no real advantage to not specifying the supplement. To the best of my knowledge, as Nate told you, I have a lot of experience as being a fabricator. Whenever I specified F1554 grade 55, whether I specified the supplement or not, that's what I got. I got a supplement S1. So there is there's no disadvantage to specifying it as S1.
And can you say whether it's possible to add that supplement to grade 105 anchor rods?
No, it is not. If you read F1554, the supplement is only available to grade 55. It's not available to grade 105, which means 105 is never weldable. So keep that in mind. If you specified F1554 grade 105, it will not be weldable.
Okay. I'm going to go back. There are some questions that have come in about the steel that has atmospheric corrosion resistance. A588. Is this the same thing as galvanized steel, or does this steel have to be galvanized to have its atmospheric corrosion resistance?
No, it's a rather unique steel. It was developed actually originally by U.S. Steel in the late 1960s. It is a material, steel, that it actually, through the process of wetting and drying, it seals the outside surface. It gets a rust color, but it seals the outside surface so it will not corrode all the way through. So it's a special formulation that is used to produce A588 material that it just rusts and then seals itself. You'll see it very commonly in a lot of in bridges is where you most commonly will see it. There have been some buildings. There's a building in Chicago that is actually faced with A588 material. The U.S. Steel building in Pittsburgh is all A588 material. So if you ever go online and try to look at pictures of it, you can go look at those pictures and see what that material looks like.
All right. Okay, so that unfortunately is all the time we have for questions. Thank you again to Larry Kruth for presenting this interesting topic today, and thank you all for joining us. Have a great rest of your week, and we look forward to seeing you again at another AISC live webinar very soon.